Okay, hello, my name is Lê Đức Vượng, and today I am here to present about pointer and data structures. What's okay? So we must first define what pointers are, and to first define what pointers are, we must define what memory is. Okay, so memory in this presentation will be referred to full-time memory, and you can imagine a volatile memory here as a really long tape that's divided into cells like this. And each cell contains a value and also each cell has their own address like this. So this is a hexadecimal value. And when converted to decimal values, it will look like an integer. So keep this fact in your mind because I'm going to go over it later. The definition of a pointer is a variable that points to another variable's location in memory. Dereferencing a pointer will give us the value of the memory locations that it is referring to. So here I have this variable a, which is pointing to this asterisk a variable's location in memory. And this value a here, which is the pointer, when I put an asterisk in front of it, it will become dereferenced. And here it will give me the value, which the green value, which is represented here. So now you may be wondering, but this green value is spanning for more than 2 memory slots. It's this slot and this slot. So how does the pointer know where to point to? I mean, is it going to store the address of this memory slot or this memory slot? How's it going to know? Well, in that case, pointers will point to the base memory address or value. That value spans more than one memory slot. So what is a base memory address of a value? Well, the base memory address of a value is merely the value of which that is the memory location of which that value starts from. So in this case here, the a variable is going to store the address of this memory location because the green value starts stemming from, you can say stemming from this memory slot. Okay, right. Next up, pointer arithmetic. So you remember that when I told you back then that when pointers converted to hexadecimal, when converted to decimal will become an integer. Well, here we can use that fact to do pointer arithmetic. So looking from this picture, you can kind of see that this dereference pointer a is this yellow value, and then the dereferenced a plus 1 is the sign. So you can think of it like moving forward one step from this yellow value, and then moving forward 2 steps from this yellow value is of course this red cell, and moving backwards 1 value from this yellow value is this green value. Now range are integers, so we can do arithmetic operations on them as mentioned before. However, we can only do addition and subtraction only, because it doesn't make sense if you multiply a pointer with a constant. Okay. Also, it doesn't make any sense if you take the power of it to the n, or you take the square root of it, which is hilarious. A pointer will move n addresses starting from the address which is pointed to when we add n to the pointer. So Here you can see that if I add 1, then it goes forward 1. If I add 2, it goes forward 2. Minus 1, it moves backwards 1, just as you would expect. Okay. About data types, which it's a classification of data that specifies which operations can be done on them without causing errors. So it's like saying that you can take the square root of a decimal number, but you can't take square root of Texas. It's impossible. So it's like that. You classify that these are Texas, but 0, 1, 2, 3, 4, 5, those are natural numbers, or more generally integers. So examples of data types are floats, which is just decimal numbers. It's just a fancy way of calling them. Integers, which we all know what they are. Characters, which is what you see on screen right now. Booleans, which are values that are true or false. All right. Next up, data structures. It's a method of storing data such that they can be easily accessed and efficiently manipulated. Each data structure is designed for a particular purpose. So, for example, if you want to be able to access elements using their indexes, so maybe the section number 2 of the lesson math number 21, then in that case, if speaking in computer science context, then you're looking for the array. But if you want to refer to the values as the key, like a dictionary, so the definition for data or the definition for structures, in that case, you're looking for a data structure called hash maps or hash table. Choosing the right data structures for a project largely affects the final result of the project. So choosing the right data structure is a very hard task, and it usually takes lots of practices and trying to solve problems daily to be able to choose the right data structure. But for common ones, though, you usually learn them in university. For particular problems, though, it's up to you to do that. All right. The first data structure that I'll go over is used in a lot of general algorithms, which are arrays. Okay. So what's special about arrays? An array is a data structure that contains a positive integer amount of data values, which must all be of the same data type. So for example, integers. So they must all be integers in here, or they must all be floats in here. They can't be of the different data type. Arrays maintain their elements orders, meaning that elements can easily be accessed. So if I tell the computer that this first element of the array is orange, the second element of the array is red, then it's always going to remember that information. And whenever you tell the information to access and give you the value of the first memory location, it's always going to give you orange. It's not going to give you red in any case. Okay. When arrays are initialized, we must specify their size as they have fixed length. However, we do not need to use all of the allocated space right from the beginning. So here I have an array of 6 elements, and I have 2 spaces here that is reserved for emergency cases. All right, next. New values not intended to be added to the array cannot be stored in pre-allocated memory locations. So for instance, if I want to add the number 2 to the memory without wanting them to be stored in the array. I only need to tell the computer to add that number to memory. I do not need to tell it to not put it in the array. Okay. Elements of an array can be changed. So if I have this number 1 here, I can change it to 3, or I can change it to 7. I can change it to whatever elements, whatever value I want, as long as it's still an integer, which is the same data type as the first one. Multidimensional arrays, which, well, that are arrays that store a positive integer amount of arrays in itself. So here's a little special array. So it's an array that stores arrays inside of it. So arrays can be used as elements too. But it comes with a catch. All child arrays must have the same size. So since all child arrays must have the same size, we can represent this as a table. So this square here, no, this rectangle here is the big array, the father array, as I would call it. And here the child arrays must all have the same size. So this child array number 1 has 3 elements. This child array number 2 has 3 elements, and then so on and so forth. When we want to access an element, we must first specify the index of the array, which has an element, and then the index of that element. So say if I want to access the second elements of the first elements of the bigger array, then I must say the first elements of the big array, and then which is this array, and then the second element of that first element. Of course, this is only for multidimensional arrays. If you do that on a normal array, you just get an error. In the case that not every child arrays have the same size, so for instance, a big array that has the first integer as a 3-element array, the second element as a 5-element array, then that's called a jacked array. All right, so that is multidimensional arrays. It's pretty common, and it's also particularly useful in some cases. All right, finally, I want to go through array lists. So here's a little question for you. Arrays are non-resizable, as you have heard from the previous section. So what can we do to fix this little caveat? If you want to think about it for a little bit, you can pause this here. But if you want to jump straight to the answer, here it is. So by copying all values of an array into another bigger empty array whenever that array runs out of space, and deleting the former array, we have resized the array, thus giving us more space to work with. So if I have an array that contains the value 1, 2, 3, 4, which are all integers respectively, and it only has 4 elements, meaning that I have filled all of its places. But suppose I want to add the number 5 to that array as well. So I would create an array of maybe 6 elements, which is all empty now. And then I copy 1, 2, 3, 4 to that array. And then I write 5 to that array. And I delete the full array from the 4. And this is this is basically the data structure array list. It's just an extension of the array. All right, so that is the end of this presentation. This is the first time I've ever done a presentation of this scale. And so mistakes are unavoidable. And if you spot any mistakes in my presentation, please tell me. Also, data structures are regarded as one of the hardest things to be learned in computer science. So I hope that I've did nothing wrong here. All right, that's it. Thank you for listening and goodbye.